In this lesson, we're going to talk about rational functions involving polynomials. We're going to try to find zeros and vertical asymptotes. So the rational functions that you're going to see are going to be in the form f of x equals p of x over q of x, where p and q are polynomial functions. Written in standard form, no common factors other than 1. You can find the zeros for when the top p of x is equal to 0, and you can find the vertical asymptote where the bottom q of x is equal to 0. So zeros, remember that's our x where it crosses the x-axis, can be found when the top is equal to 0, and the vertical asymptote can be found when the bottom is equal to 0. This is the simple concept that you just need to remember. If you want to make a note of it, that would be a good idea. So if we want to identify the zeros and vertical asymptotes of f of x equals x squared minus 2x minus 3 over x minus 2, we can do so by first setting the top equal to 0. That'll give us our zeros. If we set the bottom equal to 0, that'll give us our vertical asymptote. Let's start with the top. Let's say we have x squared minus 2x minus 3 equal to 0. The way we solve this is by factoring. So we need to multiply to get negative 3, add to get negative 2. Well, that's x minus 3 and x plus 1 equals 0. We're going to set each one equal to 0 and solve. And we're going to be left with zeros at x equals 3 and x equals negative 1. Those are my zeros. The vertical asymptote happens when the bottom is equal to 0. So the bottom is x minus 2. We set that equal to 0 and solve. And we get x equals 2 as our vertical asymptote. Now the second part of this is to graph. So I'm going to change slides here. But again, we still have the zeros at x equals negative 1, x equals 3, and we got our vertical asymptote. I might have changed colors, but that's okay, is x equals 2. It's all written right here. When you graph this, what you need to have is have the vertical asymptote graph correctly. So here's the line, vertical line, where x equals 2. There's our vertical asymptote. Now you can set up the zeros by plugging in x equals negative 1 and x equals 3. You plot the zeros at negative 1, plot the 0 at 3, and your graph would look something like this. Actually, more like, we plotted at x equals 3 here, and it would be more like this. So let's try one more example. So if we want to identify the zeros in this problem, we have x squared plus 7x plus 6 over x plus 3. We need to set the top equal to 0 and solve. We're going to factor that and multiply to get 6, add to get 7, x plus 6 and x plus 1. So that means our zeros are going to be at x equals negative 6 and x equals negative 1. The vertical asymptote is going to be x plus 3 equals 0. We're going to subtract 3 on both sides and we get x equals negative 3. This is the most important part of the graph, the vertical asymptote at x equals negative 3. I'm going to draw my vertical asymptote. That means the graph is never going to cross that line. The zeros are going to cross at negative 1 and negative 6. And our graph would appear appear to look something like so. And there's our rough sketch. You can use your calculator to help you graph. The main things I'm looking for is when you find these numbers, I need to see the crossing the axis at those numbers. Actually, might have been off there on that -6, huh? 3, should have been right here. I apologize. Easy to screw that up. So I'm looking for it crossing right here. I don't need anything else very perfect at -6, at -1, and I'm looking for the vertical asymptote line at -3.